Good afternoon, dear colleagues. Thank you very much for joining us today. During the next hour, my colleague Daria Nesterova and myself, Ivan Kuzmenkov, will talk about app performance analysis in clustered environment HCL Domino. A couple of words about myself first and about my colleague. Many of you know me. I represent a company Growth Tactics. I have been working with Domino since 2005, and I think that it is the best platform in its group. We also are partners of the companies that introduce document automation. And my colleague and my co-host today is Daria Nesterova. She will present herself. Well, fortunately or not fortunately, I don't have so many achievements and accomplishments. And Ivan, I used to be just an ordinary net developer, but in the future, I really hope that I will be a true sysadmin in DevOps area. I have joined Growth Tactics this year, and my focus is optimization domino on Linux and DevOps introduction in companies. Well, let's talk business. Premises for our talk and premises for our work in general. Last year, one of our biggest customers had a project and it transferred from one obsolete system to a modern system, Lencaset 371. One of the biggest reasons for this transfer is the necessity to support companies' growth. And it was a huge growth from more than 1,000 to several thousand users. And it was a very complicated issue in terms of administration. So for that reason, it was decided to transfer to a web-oriented version of Linux. Well, you know, in theory, it was beautiful, but in practice, there were several bumps and challenges. After months of introduction and setting, unfortunately, we could not see at once that the system worked perfectly and seamless, and our customers naturally had a question, what's wrong? So, first of all, we have to explain it to them, why the system isn't as seamless and flawless as it had been expected to be. And secondly, there were also other issues related to DevOps. An Internet Cluster Manager, ICM, was used, and its issue was to transfer those who entered the joint URL to separate hosts, and it triggered several complications. And of course, our customers were not happy with it. Besides, we realized that for analysis, we have to read logs. We have to read them, we have to analyze them in web applications. And it also required specific architectonic solutions. We have tested several options for a joint starting point of the app, Apache and Isomix, but ultimately we decided to use a reverse proxy. When we launched it, our work has become significantly more easy and nice with this single starting point. But unfortunately, this system doesn't allow us to read logs. So there were still these issues with logs. We decided to think about it a little bit more, and we have implemented a plan for the solution of this problem. It was a new area for us. It was the first time when we participated in this large-scale project. So naturally, we had to collect a big amount of data in web applications. We also needed an opportunity to investigate every error, every complication. We had to realize why a specific task takes so long for a specific task to be accomplished. And we also needed an opportunity to retrospect each of these errors to optimize system functionality and systems interface. Another important point was to help the first and the second support line in dealing with every issue, about every case of systems freezing. It turned out that when we started implementing this solution, our customers realized that they can monitor the set as a service. They can read records about metrics. They should need data about number of users, about distribution between nodes, between clusters, you name it. And every single aspect could be included in the solution that we are about to talk about. What did we have at the beginning? Thanks to the wonderful developer, we started producing Domino on Astra Linux. We love this system, and we are still very satisfied with this. We are really happy, and moreover, our customers are really happy. It allowed us to use our Russian version of Linux. To talk about platform, we use Domino servers, and gradually we introduce a clustered system. Thanks to remote branches that allow us to work with local servers. Besides, we have a documentation set 3.7.1, and we plan to transfer to 3 and 8. And in terms of river proxy, in terms of starting point, we use HAproxy. It's a reverse proxy. It balances loads depending on services and engages in logging. Well, we decided to use HAproxy, and we understood that logs are accumulated, about 1 gigabyte of logs per day. And we understood that the amount would decrease. So by the end of the year, the amount will make up about 4. So we decided to think about where we can analyze these logs and where we can collect them. So our first idea was absolutely natural. By transferring to a new system, we decided to use Psi1 service thanks to Vladislav Tatarintsev. Besides, we needed an assistance so that we are told how we could deal with this issue, this complication in terms of visualization of data and log collection. We decided to use Zabbix, and for me it was clear that Zabbix is used for some other areas, but there was a consultant who assured us that he will deal with this. But unfortunately, after a month, we saw that the result was not achieved. There is a link, actually, you can follow it. I think it can be useful for you. I would recommend you to follow it. So we started using Zabbix, and we decided then to refrain from Zabbix to keep our logs there. And our next step was to use Elasticsearch base. First, its name was Elasticsearch, then it became Elastic Stage. And apart from this, we used Kibana. So I also recommend you to use it. Pavel Loginov, the developer of this project, he develops HAproxy VI. He can consult you, he will support you, and I would recommend his product. After this, I would like to, after this, Daria Nesterova joined our project, and we have been very satisfied with this collaboration. So Daria, please tell us about your part of the job, about your experience. Yes, good afternoon. Pavel Loginov helped us to achieve success. And thanks to him, we found a right solution. He gave us proper tools that allowed us to deal with the issues and challenges before us. So during our work, we could collect a program complex used for data collection and data analysis. During this period, during the development, we gained an understanding that Elastic is the best solution for log storage, but Grafana is the best option for its analyzing. So we started from Elastic and Kibana, and now we transferred to Elastic and Grafana. So what are the advantages of Elastic Stack in our case? First of all, it is relatively easy to set it up because this tool allows us to see the result relatively quickly, both in test and production environment. So basically, we are talking about just correcting our configs. Web interface of Kibana is very convenient because it can be integrated with Elasticsearch via API. So if we're talking about classic solution, you have to make a request to base or to Elastic Index, and it is done manually. But if you use Kibana, you can make it easily via interface. So to collect logs with the data that are necessary for us, we have chosen to use so-called FileBeat. And FileBeat specializes on reading logs, so it was an obvious solution, no-brainer for us. Why did we decide to refrain from Logstash? Logstash is a part of Elastic Stack. For that reason, I have to tell about this. Our entire team are classic system administrators, not programmers. For that reason, syntax of mutators was a little bit frightening for us. Take a look at this example. It looks more like JavaScript. I'm talking more about arrow function. And for Elastic, it looks more conventionally. It is a processor that replaces one symbol with another one. So it's a classic option, conventional option, and it looks more like logs. And it was more suitable for us, more convenient. Then we thought that additional programming node will reduce fault tolerance, and file bit appeared to provide us with all functions that are necessary for us. So it was obvious that a log stash was not necessary for us, and it was easy for us to refrain from this. So how does our system work? We have a program, Domino server. It includes web server. So a web server and Domino server log some activities in access log and in console log. And there is also a balancer that logs requests from users in HAproxy log. All this data are collected by FileBit, and FileBit guarantees that it should take every new record at least once, but not more than once, so there won't be any duplication. This new record gets into Elastic, but before it gets into a database, Elastic, thanks to processors, processes this data, this record, and then puts it into a database. Then Kibana requests this data from Elastic and shows us so that it is convenient for us to analyze it. So what is taken into Elastic? These are records from access log, console log, and HAproxy log. How did we enable login in access log? Configurations, server document, internet protocols, HTTP. So two sections are important for us here. You can see them to the right. So you enabled extended format of logs. You should enable log daily, log file, and mask for a file. It is access for us. This is the way we decided to have. Then login in a console log. You go into configuration, server, then configurations, then bookmarks. You use interface to add console log enabled. Then these logs will be saved in catalog IBM support. When we set our system, we saw that there are a lot of requests to resources with pictures, with images. So we disabled it in our settings. You go to web, to internet sites, and you add rules. A rule, I would rather. And this rule cache these formats of files. So please don't forget about fav icon. In our case, the weight of this icon was 500 kilobyte, and we decided to replace it. And through that, we could reduce our load on traffic, and it was a very convenient step for us.
We do not remember. You do not need to remember everything. We will definitely send you these configs, but mainly we had to write the log format manually, and this is how the requests from users are stored. Also, it is important that HAproxy and FileBit duplicate everything in the logbooks. And if you do not stop this process, those logbooks will just be overrun and the space will be insufficient. Of course, I will not pronounce it. You can view it in the presentation I'll send. You just add a certain line into HAproxy file and in the FileBit file. And this line will protect us from this unfortunate duplication process. And the final system variant, as you can see it on the slide, is the Domino server cluster for servers, a balances server. Each of them is logged into a separate log file for console, DOM-log, HAproxy. It is taken by FileBeat and then moved to Elasticsearch. So nothing too overly complicated. This diagram also shows you ingest pipeline, an embedded mechanism of Elasticsearch. Let's take a look at this process. A log file is taken by the FileBeat, moved to Elastic at the Elastic server ingest pipeline, which is a certain config, runs several processes that process this entry a certain way, and then it is put into the Elastic index. One should note that it is quite unconventional that a base is an index. So if you put something in a base, you index it. So how does the pipeline look like? It's just a screenshot from Kibana. You can see that it is quite readable thanks to Kibana. First of all, this is the commentary for us. Then there is a grok filter that is a parser, a bit like a regular expression that divides the initial complicated message. This complicated log format is divided into attributes. I will show you how great it works. Also, an important processor, what to do in case of a failure. You should definitely use it. And the processor that puts this entry through the pipeline to the Elastic base, to the Elastic index. What do I mean when I say that Elastic will halt its work in case of failure? That is basically it. In the Elastic documentation, it's clearly written that the default mode is, in case of the first exception, everything will halt. In order to avoid that, you can add this processor. Of course, you can ask why you need to do that specifically, but the documentation doesn't answer that question. But there has to be a reason for that. FileBeat settings. We're interested in just two sections, input and output ones. The input section, you see the red outward arrows where the entries are taken from. And these yellow dots show us that apart from the entry itself, we also have a log type attribute with the meaning of the log type, DOM-log or DOM-console. So output is where the entries are put. We have a live hack by FileBeat. If we have a log type attribute and it is DOM-log or DOM-console, we put it into a certain pipeline, access log or console log. So let's go back to the pipeline config. We said that we want to put it into access log since it's DOM-log. It will be processed and then put into the Elastic index. Once we have all our configs in place, what do we see in Kibana? We see that here we have all our DOM-logs for each separate day, and everything's functioning. What else do we have? We have to go to Discover. That is a section when we can see our logs. We choose the index, and we see the entries and the format specified. They go top to bottom. I may just go into a little bit of a detail about that. Just a couple of slides back. I was more of a manager in this case. It is very advanced what Kibana and Elastic provided to us. Everybody knows this problem that if we go from HTTP to Domino, this base is so overcrowded, is so expanded, just a gigabyte per day. When we worked without this solution, analyzing anything in the NSF format, searching for requests, finding long requests was extremely inefficient and cumbersome. It was too slow. Domino is does not specialize on it, so it's not created for this purpose. There is a great solution to keep your logs and analyze them. Another important thing is that why we discontinued our work with Zabbix and Scion, the Domino itself keeps these statistics, but doesn't go deeper and into the server statistics and doesn't transfer these entries. The log entries are kept in the NSF format. It's extremely hard to sort it out from this format. The vendor's solution has been great in this case, having your outside platform to process logs. In the Domino, in the server document, you have a certain setting so that all the logs are in the text files that can be later processed within a separate solution. So imagine there was 1.5 gigabytes of logs, then heavy requests, the views. The indexes just grew and swelled. So when we realized that it is just a couple hundred megabytes in the Elastic, and it is so agile and quick in Kibana, we can process all the requests. We really find our targets, a certain request, the timings that we're concerned with, or a separate user, and we search for a specific username. We have an authenticated user and we see all the DOM logs. So the point is, Elastic Stack allowed us to work very conveniently with all the logs, saving on the time, saving on the space, saving on the administrator's nerves. That is great. So if you have the same issue with the logs and that it is all very clunky and cumbersome, please search for external solution, for example, Elastic Stack. And I give the word back to Daria. Thanks to the filters that we employed, our complicated message that we received could be separated into several attributes. Let me comment in Ivan's words. There's the username, but for the reasons of confidentiality, we just cut it out. There is the data there. And those are the metrics that we think of. These are the metrics within the HAproxy documentation. We believe that they really reflect the user experience of our application. not just what we see and register at the Domino server, and not what we see when the documentation filing system is processing, but the true user experience. One might comment on it, how we really achieve these metrics, because there was quite a winding road to these metrics. Yes, it was indeed challenging. Everyone understands that working with a web application or CRM is a data flow. It passes through several nodes, through several programs, HTTP, Domino, HAproxy, some of the requests in NSF format. One thing is what we can register at the DOM log side. At some point, we saw that it was out of touch with the user experience. With certain requests, we saw that there was a difference between what our technical services see and what our users see. We do not understand what's happening on the user's side. So the reverse proxy organization and the way that HAproxy is registered allowed us to approach this user experience. With these HAproxy logs, we see how it really functions on the user's side. Well, unless there are some problems with the computer or the user's browser themselves. We found it was really valuable to close these gaps. And these metrics helped us understand what was really going on. For example, the requests by client were not right. We found out that it was another factor, and that the package exchange could also slow down. It's not the system itself that is slowed down, but it is the sending of the message on the user's side. So we had all our data to prove it. Another piece of valuable information is termination state. Apart from the entry itself, it is saved. You can see the way it looks like. This is the normal request and how it's reflected, with a status code 200, normally processed by the Domino server. This is the request from the client. It is all deciphered here. Just as a side remark for you, in order to understand how these requests function, it is a great feature and it is a great tool to see it. What we really saw in Kibana, when we put in place our metrics and saw these in the logs, there are certain timings that appear at each stage of the request lifecycle, starting from the balancer, going to the data exchange, the protocol, the Domino service timing, and the overall time that the user had to wait for his request to be implemented. In order to consult the first and second line, it was really helpful till we found a practical solution of accelerating our applications. I will also provide my commentary on this part, talking about our results. it is great that we started seeing those detailed logs, seeing the movement of these requests and request packages. A web application in the modern world means a lot of simultaneous requests. One loading means several dozens or hundreds of those requests. So you need to see what slows the process down on the client side, for example. So this detailed view of the package showed us what's going on so we can explain it to our customer, where we could improve that, we could do something with the latent processes, take a look at the equipment, what could be changed, at least put a patch on, upgrade, or sometimes see that the base is working slowly, and that's what we work with. So there is a whole new wonderful world that opened up to me as a manager when we could put in all the settings for the graphs and to see how separate quests function. There's a great example. I think we have about 15 of those metrics, not over 20. There are typical operations within the systems that the client faces. Renew the page, open a document, create a new card, choose a counter agent, etc. And we see all these requests in Elastic. We put all those requests into dashboards and graphs and monitor these requests. First of all, we calculated the number of those operations, and then we started analyzing at which point do we have the situation when 80% of processes are performed in 4 seconds. For many operations, it is even less, 3 seconds. It is a wonderful tool to do that. On your screen, you can also have an annotation, what type of graph it is, how it is measured, how it calculates everything. So this tool allowed us to talk very precisely with the customer, what's going on in the system, how much it is slowed down, or if there are some other factors at play. And let's go back a slide. So it is very inspiring that we have a tool to show our customer that we have this or that number of requests, that they're mostly processed without any faults. For 400 and 500s, we could have separate incidents, but we realized that it was still within the norm, that there was no access, or that some documents were overfilled. HTTP could not process this. We had a tool to explain what's going on, and we could explain it to our customer.
So, in terms of recommendations, there is a wonderful graph in Kibana. These all are Elastic components, and Daria will go into details about this. We have talked about Grafana, we have already mentioned it, but still, even in Kibana, there are wonderful templates. For example, this warm chart that allowed us to collect all type requests and just build a quantitative characteristics about the number of requests per day, per week, etc. Based on this, we could agree upon a roadmap with our customers about what we are about to optimize. And I think it's a wonderful tool for administrator, for business users as well. So it shows where the system is going, what are we working on, and what are we about to optimize. As a result, we have 4 most massive requests, and we will end on it till the end of the year. And I hope that in the nearest future, we will be able to give you more details about this data optimization of a system. Dasha, over to you. Let us take a specific example of dot tuning of a specific mode based on the graphs that we constructed. There is a top of most loaded, most slow modules. So we were working with in-house team of our developers, and we reached a solution with a specific module. We were talking about preview of specific documents in different formats, PDF or Word. You can see here a very good example presented in graph. On top, what we used to have, a typical day during rush hour from 10 a.m. to 5 p.m. It's a typical business day, and we can see here that among requests longer than 5 seconds, these requests reach the bar of 50. Out of all requests for file preview, out of 450, 50 took more than 5 seconds. And after the optimization, their amount of this requests dropped significantly, even though there were more requests this day. I think that it is very obvious, and I would like to remind you that it's just a tuning of one specific module. And even this specific module or this specific tuning allowed us to see where are these bottlenecks and how we can optimize the system. So in summary, what did Elastic Stack gave us? What did it give us? It allowed us to replace log NSF and DOM log NSF. It provides us with nice data visualization. Also, it gives us an opportunity to assess performance of Domino, multiple filters, metrics, etc. Also, we can provide reports for our clients, and this is one of our main tasks. And last but not least, it's a type of protection from complaints from our customers. Then, advantages of Elastic Stack. First, we have a web interface for administrating, then a very easy way to set the system up. We just copy our configs and this is it. And also it is relatively easy to introduce log collection from any subsystem of Domino. Let me now give the floor to Ivan once again, so that he can tell about our goals and our further development. Yes, I think we have just a couple of minutes, so let me be short here. We have just 6 minutes. Okay, thank you. Okay, then in the 6 minutes, let me summarize the talk and tell about our goals. This solution gave us a very nice tool to to negotiate with business users. But I think you are familiar with all this. After audit, after tuning, there still can be some problems, but luckily, IT departments of our customers and our company, we have this nice tool so that we can say that everything works fine, or it is not the problem of development. Unfortunately, common users still tend to think that any system problems and any challenges are the responsibility of SAT, because they remember the time when document automatization was a problem of developers. But after we add extra capacity, we see a dramatic drop of these issues. And during monitoring, we could see, and we presented it, demonstrated it to our customers. There's no secret here, I can show you it here. When you use new equipment, and this equipment corresponds to the sizing of vendor, then Elastic shows dramatic acceleration of work in metrics. So if there were still any complaints, then we could easily say that it was not because of us. We have now this tool, and we also have data that presents and demonstrates that everything works fine and the system keeps accelerating thanks to the combination of Elastic Stack, HAproxy, and Grafana. Yes, there are new requirements because, you know, customers keep saying this, everything works fine, but we need a better system, so we keep working on this. These new requirements also include distributed environment of Domino servers. And our customer also wanted to have a monitoring system so that it can collect data from every platform and monitor this data. And we have found this decision, we have tested it. We license Apache 2.1 gives you this. So this solution is Elastic HQ. It's a project of Elasticsearch enthusiasts. And this system allows you to monitor all Elastic clusters available to you. And I think that it is very, very convenient. We have tested it and we agree it is very convenient. In terms of where we are about to go there in the future, the system is being improved constantly. And if you want to improve it, you can transfer your graphic representation of data in Grafana. You can launch Elasticsearch in Docker in distributed platforms, and also provide fault tolerance with Zabbix triggers. I think that this is our goals for the nearest future. So we will experiment in data collection and we will improve our work. This is an end for our talk. So if you have any questions related to this topic, we will be happy to answer them. You can use this email address. Our technical specialist will be glad to answer any of your questions. Thank you very much. Thank you, Dasha, also. It was a wonderful presentation. Ivan, Daria, thank you so much. We don't have any questions so far. So it is good because you had enough time to finish your presentation.